Everyone, so as you can see here, we are working on our thermal energy roadmap. So the first thing that you must do was this Edpuzzle that was giving you directions for the rest. And then we went into task 1, which was a review, task 2, which is also a review, 3 and 4, which is all reviews. Next, you had a Newsela article about dew. Then you had a Google form, which was a KWL form about dew and condensation, about what the Newsela talked about. And here is like an instructional video of more in-depth knowledge. So what we are doing in this mini unit is to combine states of matter and the molecules. So I don't know if you remember a while back when we talked about solid, liquid, and gases. And then our next science unit was molecules, atoms, compounds, and elements. We're kind of combining the two. So the first thing that we're going to talk about is what is dew? Have you ever gone on a morning walk and noticed how peaceful it could be, but there's water on the ground? So how did that water get there? Because it didn't rain. Where did it come from? Why is it there? So it is there because it's this thing called condensation. So the air that we breathe contains particles of water. The water in the air is visible because it is in a gas form. As the cold air hits the water vapor in the air, we see condensation, or those visible particle drops that turn into liquid. Check out this video to see examples of condensation. We're not going to do that. There's going to be the next video is going to be about condensation. Some other examples of what you can see is your glasses fogging up on a cold day, or beer fogging up when you take a shower. Think of like when you would be wearing a mask and you would, if you wear a mask and have glasses, you see it's hard to breathe because it fills up your glasses. So the next thing we're going to have to backtrack is matter. So there's 3 states of matter. We have solid, where the particles are really, really tight together, liquid, where they're free-flowing past each other, and then gas, where they really bounce off each other. So what we are going to do is that you add energy. This is the step that we're going to add from what is new material. We're going to add energy in each phase transition. When we add energy, we have to know what happens. That is a phase change. So this is about the physical state and the energy within the atoms. So we know that solids are really, really hard and brittle. Liquids flow past each other and gases are all around us. But look at water. Water can be formed in a solid, liquid, and gas form. When water is a solid, it's ice. When water is a liquid, it is H2O or just water. And when solid is a gas, it's steam. So how do we get it from changing each phase? So to get a solid to a liquid, we have to add energy. To get a liquid to a gas, we have to add energy, which is all in this chart down here. So matter can change from one state to another. We know that. So as we just go from a solid to a liquid to a gas, we are just increasing energy along the way. But there's this, it all is about temperature. So when we're saying adding energy, that also can be substituted for turning up the temperature. So let's say you have an ice cube, and then the ice cube melts in a pot. Then it turns into liquid. If you keep it on that temperature and its temperature increases, you're going to increase it to steam and it's going to evaporate. So the key words that transition here are: from a solid to a liquid, it melts. From a liquid to a gas, it evaporates. Those are keywords there. So, but we have to go back and say, what is a physical change? So molecules could move from one state to another, and this is called a phase change, but it does not change their atomic structure. So what that's saying is that even if you change ice to water or water to steam, it is still composed of H2O, and that's not going to change. So what can cause a phase change is either temperature or pressure. So as I said before, our key word is melting. So melting is from when we move to a solid to a liquid. So solid to a liquid, that means we've added energy for it to change. Next, we're going to go backwards. From a liquid to a solid is freezing. Think of if you're making ice cubes or making ice cream, that would be freezing it. Then if we go from a liquid to a gas, that's evaporation. So think of when you would be boiling water and that little steam come out, that's evaporation. And then from a gas to a liquid is condensation. So those are our words that we're going to focus on here. So water is the main one that we're going to focus on. So water covers about 70% of our earth and is the only substance that can naturally change between a solid, liquid, and gas. And we're going to talk about that here in a second. And then that is the end. If you have any questions, let me know.